Okay, please recall that square root of 25 is 5, just a plain old 5. It is incorrect to write root 25 equals plus or minus 5. We have not talked about the symbol um, really, and it will come up, but while we're dealing with expressions, this is not the time for this. So when given the expression root 25, this simplifies to the positive number 5 only by convention. So when does the plus or minus sign appear? Well, if you have an equation, sometimes it's convenient to square root both sides, to take that action of applying a square root on both sides of the equation. That's when you introduce this plus or minus symbol. Okay, so plus or minus appears when you're square rooting. It's a verb or an action. It doesn't, so this action is performed to both sides. So for example, just tiny example, given x squared equals 25, if you square root both sides, you'll have x equals plus or minus 5. Okay, so this is really, the thing is, if you just have the expression root 25, it simplifies to just a plain old 5. That's an expression versus over here x squared equals 25 is an equation. This is another reason, this slide is another reason to think about the differences between expression versus equation. So simplifying an expression, there's never going to be a plus or minus sign. When you're solving an equation and you take that step of square rooting both sides, then you must introduce a plus or minus sign. Let's say some things about functions that have radicals in them. This would be good function review. So for what values of x is f of x equal to root x plus 7 defined? And for what values of x is f of x undefined? So recall that square rooting only gives a real number if what you're square rooting is greater than or equal to 0. So here's the thing. We need the stuff inside the square root. I mean, truly the contents inside the square root to be greater than or equal to 0. In this example, the contents inside the square root is x plus 7. So we need x plus 7 to be greater than or equal to 0. Right? That's the stuff inside. So the root tells us where to look, and inside the root is an x plus 7. That's what we're rooting, what's in yellow here, and we need that to be greater than or equal to 0. So this happens when x is greater than or equal to negative 7. So in summary, f of x is defined when x is greater than or equal to negative 7. And on the flip side, f of x is undefined when x is less than negative 7. Yeah, and you're reading this right. X greater than or equal to negative 7. Yes, x can be negative and you still won't end up square rooting a negative. Here's an example. Let's look at negative 3 as our x value. Negative 3 is bigger than negative 7. And when you apply the function f, so you have f of negative 3, go to the top, right? And that should, f of negative 3 will turn into root negative 3 plus 7. So inside the radical, this negative 3 plus 7 simplifies to a 4. So you have root 4, which will end up being 2. There we go. There's our number. We got the real number 2, even though we plugged in this negative x value, negative 3. Here's the thing. It's because we never square rooted negative 3. We ended up square rooting negative 3 plus 7. In other words, we ended up square rooting the number 4. So that's fine. We square rooted the positive number 4. Let's try another one. For what values of x is f of x equal to root x plus 10 defined? And for what values of x is f of x undefined? So now, the thing we're square rooting, I've tried to highlight it within the notation version a little more carefully. The thing that we are square rooting is x plus 10. And so we need the contents inside the root, that's the stuff that's in yellow, and just the stuff in yellow. Notice the yellow is avoiding the root symbol itself. It's just the stuff inside the root symbol. We need the contents inside the square root to be greater than or equal to 0. So we need x plus 10 to be greater than or equal to 0. This happens when x is greater than or equal to negative 10. So f of x is defined when x is greater than or equal to negative 10, and undefined when x is less than negative 10. So again, x can be negative, and certain values anyway, and you still won't square root a negative. Let's see. For instance, negative 1, right? Negative 1 is an x value that is greater than or equal to negative 10. And when you do f of negative 1, you'll have root negative 1 plus 10, in other words, root 9. Again, in yellow, that's the content inside the square root. And root 9, good thing 9 is positive, root 9 equals 3. As a follow-up question, let's find f of negative 10, which should exist because negative 10 is greater than or equal to negative 10. A little typo there, sorry. F of negative 10 is equal to root negative 10 plus 10. In other words, equal to root 0, which is equal to 0. So we did here get a real number, namely 0, because root 0 equals 0. Okay, for what values of x is f of x equal to root x minus 6 defined, and for what values of x is f of x undefined? So again, we do the same kind of thing. The contents inside the radical, this time is x minus 6. That has to be greater than or equal to 0. So add 6 to both sides of that inequality. X is greater than or equal to 6. So f of x is defined when x is greater than or equal to 6, and f of x is undefined when x is less than 6. Now here's the strange thing. Undefined when x is smaller than 6, including like when x is 2, right? 2 is a positive number. But because 2 is less than 6, we know f of 2 is undefined. Let's try finding f of 2. Really, right? So f of 2, just following the formula for f of x at the top, f of 2 is root 2 minus 6. In other words, root negative 4, which is not a real number. So even though 2 is positive, 2 minus 6 is negative. And 2 minus 6, or in other words, negative 4, that is what we're attempting to root. Follow-up question, let's find given the same function, f of x equals root x minus 6, let's find f of 18. So taking the formula at the top, replacing both x's with 18, you have f of 18 equals root 18 minus 6. Simplify the arithmetic inside, so we have root 12. Let's see, 12 is not a perfect square, but 12 can be written as 4 times 3, right? 4 is a perfect square, so that's the largest perfect square, which goes evenly into 12. So root 12 becomes root 4 times 3, which becomes root 4 times root 3. And then the root 4 part will simplify to a plain old 2, which is no longer in a radical. But the root 3 can't simplify further, so we just copy down root 3. Okay, let's look at the function f of x equals root x plus 3 and find f of 22. So the thing to do, just as a reminder of how this function notation works, is to write down basically what's up there, what's been provided, except we have to replace each x with a 22. So f of 22 equals root 22 plus 3, which ends up being root 25, which ends up being 5. I say this because, and even put that instruction in the blue box, because people will freak out over the next type of question. But if you treat it like the same procedure as we just saw, this next one will go okay. It's the same function. F of x equals root x plus 3, but now we have to find f of negative 3 plus quantity m minus 6 squared. Ooh, that looks scary, but look, the thing is, we should still write down f of x equals root x plus 3 with the following exception. We're going to replace each x with what was in parentheses here. Just like over here, the replacement of x was 22 because 22 was in parentheses. Now the replacement of x is, well, all this stuff that's in parentheses, right? Negative 3 plus m minus 6 quantity squared. So we just make that replacement, right? So what we end up with is root negative 3 plus m minus 6 quantity squared plus 3. So that's all inside the radical. The negative 3 and plus 3 will simplify to a 0. So we're going to be left with root m minus 6 quantity squared. The square root and the square power are going to undo each other, and we are just going to be left with m minus 6.